Hey guys, this little cute guy here is an ultrasonic sensor, and it's a great tool for electronics and for projects. You can use it to make robots, to make obstacle avoidance sensors, to make radars, you name it. Before we go ahead and get connected, let's look at what this thing is made of. So there's two kind of cylinders here which are identical looking, and one of them is the transmitter, and you can know it by the little T on the left side corner, and this one is the receiver, and that's why there's an R here. So the way this works is that it sends ultrasonic waves, and that's why it's called an ultrasonic sensor. And this one is the HC-SR04, which is the model number of the sensor, and it is one of the most common ultrasonic sensors which are used by beginners to make their projects, and also by professionals, by the way, to make their projects. It's a very reliable sensor, and it is very cheap. You can get this for $1 or even less than that if you order in bulk. But anyway, so the way it works is it sends ultrasonic waves from this end, and then if there's an obstacle, the waves get reflected and get received at this end. And the waves are really just sound waves, but they're above the human hearing frequency, which is 20 kilohertz. This one sends waves at 40 kilohertz, so we can't hear it, but they are sound waves regardless. It's got 4 pins, not the standard 3 pins that most sensors have. This is VCC, where you power 5 volts from your Arduino or from external power supply, and this is the ground, which is just connected to your ground on your microcontroller. Then these two pins are one for the transmitter, one for the receiver. One is the trigger pin, which is the transmitter pin, and echo pin, which is the receiver pin. So this one triggers the waves, and this one here's the echo back. You can remember it that way. Now let's go to the connections. I have an Arduino Uno here sitting on a tiny little breadboard, and what I've done here is I've made it simpler to connect it, so I can just insert those 4 pins here, and by doing that I'm connecting the red one to the power supply. So you can just connect it here to, like, the 5 volt power supply, which is here, but you can also connect it here because these are the ICSP headers. You can look them up if you're not familiar with those. So basically this is also an extension of the 5 volt pin. So all I'm doing is connecting it to 5 volts. I just didn't have the male pin. I had the female pin, so I can't connect it here. So I'm just going to connect it this way. It's nothing to be afraid of, nothing complicated. So this is 5 volts and this is ground. So we're going to connect these two here, like these two ends. End pins are 5 volt and ground pin, and the other two, trigger and echo, would be connected to pins 10 and 11 here. So that's about it. 5 volts, pin 10, pin 11, and pin 12 is going to ground, which is this guy here, and your connection is actually complete. All we have to do now is get it connected to my computer, and let's write some code. We have the Arduino IDE open here, and before we start anything, there's an awesome library for ultrasonic sensors which is called newping.h. No, or is the N capital? Yes. This is an awesome library. It makes everything so simple. So if you don't have your library, you can just go to Tools. You can go to, where is it? You can go to Sketch, Include Library, and Manage Libraries, and just search for Newping library and install it. It's as simple as that. Now, once we have the library installed, there's only one command that you need to set up your library, and that makes everything just so simple. It's called newping sonar, and then it takes 3 parameters. The first one is your trigger pin, which is 10 in our case. And then it takes your echo pin, which is a receiver pin, which is 11 in our case. And then you can enter the maximum distance. So these sensors can work up to 4 meters. So you can enter your distance required in centimeters, because you don't want objects that are further away than your detection area to to meddle with your readings. So if you want to just measure 20 centimeters, so I'm just going to enter 20 centimeters here, because I think that's a big enough area that you want to cover. And that's about it. You're all set up. Actually, this comes before setup, so be careful where you enter it. And in setup, we just enter our normal serial begin, and the baud rate is 9600 in this case. And just add a little delay to give your sensor some time to initiate. That's about it. And here is where your code goes. So here's where you ask yourself what you want the sensor to do. And well, I want it to detect the distance of an object in front of it and then display it. We don't have a display here, so we're just going to display it on the serial monitor on our screen. There's a simple command called sonar.ping_centimeter. And believe it or not, that's the only thing we're going to need in this code. It's very simple. But we would obviously like to print it, so we'll say serial.print the distance is, and then we would like to print the distance. So serial.print line, because after this we want to start a new line. And that's about it. I think that should do. And then we want a delay of maybe 1 second before each reading. So that's it. Let's try to run the code. Let's see, connect to the correct port, and I'm running it. Save it, ultrasonic 1, and let's run it. Let's see what this does. I made a mistake with serial begin because I didn't spell it properly. Sketch is compiling. I forgot a semicolon here. See, these are the little things that you have to actually enjoy as a programmer and not get anxiety about it. This is where your patience gets tested, but it should be okay now. I think we have done our due diligence. Okay, so it seems like it's uploaded. So let's go to our serial monitor and see what's happening. That's the serial monitor, and every second it's inputting the distance, and right now we don't have anything in front of it, so it's inputting 0. So let's put my hand in front of it, and immediately it shows 3 centimeters. Oh, by the way, this is outputting in centimeters, so if you want inches, there's a different command to it. You can do it. It's in the library, so just read up on it. Now let me move my hand a little back, and sure enough, the reading is reflected. So it's pretty awesome. I think let's get the delay to be a little less than 1 second, so that we can see the change in real time. So make it half a second, 500 milliseconds, and let's upload the code. And instead of my hand, let me put something else, maybe something like this post-it sticker. Now let's check how accurate this thing is. I have this little pen here, which is like a vernier caliper. So I'm gonna put it here. So the pen goes up to 10 centimeters here. So let's start with 10 centimeters and see what we get on the screen. Wow. Now let me reduce it to about 8. Wow. I'm impressed by this sensor. Let's go to 3. This is 3 here. All right. Wow, this is pretty accurate. I'm actually very impressed by this sensor. I mean, surely we'll be building some of these projects in our future videos on this channel. So I thank you for watching this video, and I hope you enjoyed it. Give me a thumbs up if you did. Until then, keep fungineering, and I'll see you next time.